In this video, we're going to use the unit circle to evaluate trig functions for the quadrantal angles. Now, when I say quadrantal, what we're talking about is angles whose terminal side lies on one of the axes, either the x-axis or the y-axis. So, for instance, we could talk about 0 degrees or 90 degrees, 180, 270, 360, and so on. If I was talking in terms of radian measurement, well, that'd be 0, half of pi, pi, 3/2 of pi, 2 pi, etc. So how do I find the values of sine and cosine and tangent for all these angles? Well, what we're going to do first is we're going to think about the unit circle. Now, in the previous video, we had a generic circle equation for which the center was at the origin. In this case, I've got the same equation, but now I have a 1 here instead of r squared. What that means is that I have a circle centered at the origin with a radius of 1. So if I were to draw that out here, I've got my circle drawn. If that's the case, if the radius is equal to 1, it means that the points through which this circle is passing would be 1, 0 on the x-axis, 0, 1 on the y-axis here. I'd have negative 1, 0 on the x-axis to the left, and 0, negative 1 on the y-axis down below. Now, if I were to think about my values for sine and cosine and tangent based on the definitions we just had, where we take x over r, y over r, what have you. If I want to define, let's say, the sine of 90 degrees, for instance. Well, think about this. Sine is usually equal to y over r. Well, in this case, the r value happens to be 1. So as I try to find out, okay, well, what's the value of the sine of 90 degrees? Well, in that case, it's going to be y, which is 1, over r, which is 1. Well, that means that the sine of 90 must be 1. And if I wanted the cosine of 90, well, cosine is always the x value over the r value. Well, if I'm talking about a unit circle, the x value is 0, and r, the radius out to that point, is going to be 1. So 0 over 1 equals 0, so the cosine of 90 degrees must be 0. Now, another thing that we should write down here is because if I'm talking about a unit circle, and I am defining the sine and cosine, well, the sine of theta is usually equal to y over r. Well, if r happens to be 1, that means the sine of theta is equal to just the y value on the unit circle. That'd be it. And cosine, I can do the same thing. Cosine of theta is typically x over r. If I'm on a unit circle, r is 1, which means the cosine of theta is equal to the x value of the point through which it passes. Now, what that means is that I can find sine, cosine, tangent, and the other three for my quadrantal angles, like 90, 180, 270, etc., if I can think about the point on the unit circle through which the terminal side of that angle might pass. So, putting it to work, we're going to use the unit circle to evaluate 6 trig functions for theta equals 180 degrees. So as I think about what these are going to be, my thought process first is, okay, 180 degrees. And again, as I'm doing this is something that I'm thinking through in my head. I think about the fact that 180 degrees would look like this. Well, which point on the unit circle would that go through? Well, that point would be on a unit circle, negative 1, 0. Now, and then remember that since I'm on a unit circle, I can identify sine and cosine as being just y or x. So, as I want to find the sine of 180 degrees, the sine of 180 degrees is equal to the y value of the point through which it passes. Well, the y value happens to be 0. Cosine is equal to the x value of that point, so that's going to be negative 1. Now, tangent is usually y over x, and that's still going to be the case. So now what I'm going to do is I take the y value, which is 0, and I divide it by the x value, which is negative 1. 0 divided by negative 1 happens to be 0. Now you might notice this. If tangent is equal to y over x, remember that y is the same as the sine of theta, my angle, and x is the same as cosine of theta, my angle from before. So I think you could probably put together the fact that tangent is equal to sine over cosine. A neat trigonometric proof that we'll look at in other lessons. Now, anyways, as I'm trying to find my three other trig functions here, remember that these are reciprocals of what I started with. So when I do the cosecant of theta, really that's going to be the reciprocal of 0. But the reciprocal of 0 doesn't exist. All of a sudden I'm supposed to divide by 0, well that doesn't work, so that means the cosecant of 180 degrees would be undefined. The secant, well that's the reciprocal of -1, so that means I have 1 over -1, which is just the exact same thing, -1. My final one, the cotangent, well that's the reciprocal of tangent. Again, if tangent is 0, its reciprocal is undefined. So there would be the values of my 6 trig functions for 180 degrees using the unit circle as my guide. We'll try one more. So now we're supposed to evaluate the 6 trig functions for theta equal to 270 degrees. Again, I'll draw that on my unit circle. Here's 270 degrees. And I think about, well, what point on the unit circle are we touching here? Well, that would be 0, -1. So if it's a unit circle, it means this value, the r value equals 1, so I don't have to worry about it. So as I identify the sine of 270, sine is equal to the y value, -1. Cosine is equal to the x value, 0. Tangent is equal to y over x or sine over cosine. Well, guess what? I can't divide by 0, so that means that tangent happens to be undefined here. As I find my reciprocals, the reciprocal of -1 is going to be -1. The reciprocal of 0 is going to be undefined. And now for my cotangent, the reciprocal of undefined, that's kind of a weird thing to think about. Remember that tangent, again, this is the thoughts that I'm going through, tangent is equal to y over x. And I knew from here that y was -1 and x was 0. So when I go cotangent, cotangent is the reciprocal, which is x over y. So that means this gets flipped over, I go to 0 over -1. Well, that means I end up with 0. So you can think of it as the reciprocal of undefined is 0. It's undefined because 0 is in the bottom, and then when I flip that over for the reciprocal, 0 is now on the top. Divided by who cares, it's going to be 0.